Hello everyone. Today I will share with you about kinematic linear motion. At the end of this video, students should be able to define instantaneous velocity, average velocity, and uniform velocity. And second, define instantaneous acceleration, average acceleration, and uniform acceleration. Kinematic linear of motion is the study of the motion of objects without considering the effect that produce the motion. It involves the analysis of the position of an object, velocity, and acceleration in their relation to time. There are two types of linear motion, which is motion in straight line or motion in one dimension, and the second type is motion in two dimension. For example, projectile motion. Projectile motion we will discuss in the next video. In this video, we will discuss about speed, velocity, and acceleration. Speed is a rate of change of distance. Speed is a scalar quantity. That means speed have magnitude only, and the value of speed is always positive. The SI unit for speed is meter per second. Next, velocity. Velocity is a rate of change of displacement. Velocity is a vector quantity. That means velocity will have magnitude and direction. And the direction of velocity depends on the direction of the motion. The SI unit for velocity is meter per second. Instantaneous velocity. Instantaneous velocity of an object is the velocity at a particular instant or time. Instantaneous velocity is the rate of change of displacement at particular times. It is obtained by shrinking the time interval so that the delta t is very close to zero. Therefore, the instantaneous velocity is v equal to ds per dt. For an object moving in uniform velocity, ds per dt is constant. For a displacement against time graph, the instantaneous velocity is the gradient of the graph at particular time. For example, at t equal to t1 at point q, the gradient at this point is represent the velocity of the object. Acceleration. Acceleration of an object in motion is the rate of change of velocity. The SI unit for acceleration is meter per second squared. Acceleration is a vector quantity, and its direction is always follow that of the change in velocity. The acceleration of an object is uniform when the magnitude of velocity change at a constant rate and along fixed direction. Instantaneous acceleration. Instantaneous acceleration of an object is the acceleration at an instant. Instantaneous acceleration is the rate of change of velocity at particular time. The instantaneous acceleration is obtained by finding the acceleration when the time interval is close to zero. Therefore, the instantaneous acceleration is a equal to dv per dt or d square s per dt square. For an object is moving in uniform acceleration, dv per dt is constant. For a velocity against time graph, the instantaneous acceleration is the gradient of the graph at particular time. For example, the gradient of the tangent to the curve at point Q is equal to the instantaneous acceleration at time equal to t1. When the velocity of the object increases, the object in acceleration, the final velocity is bigger than initial velocity. When the velocity of the object decreases, the object in deceleration, the final velocity is less than initial velocity. Hope you enjoy of this video and thank you. See you in next video.